All right, so Chapter 5, Lesson 5 is Simplifying Algebraic Expressions. So, Patricia, Hugo, and Son work at a music store. Each week, Patricia works 3 more than twice the number of hours that Hugo works. Son works 2 less hours than Hugo. Okay, so we're going to define our variable as x being how much Hugo makes. Okay, so here Hugo is x. Number 1 says, it says it right here. Let x represent the number of hours that Hugo works each week. And the reason we're doing that is because the description of what Patricia works and what Son works is based on what Hugo works. Does everybody understand that? Okay, so the number of hours that Hugo, Patricia, and Son work can be modeled as shown below, and we want to write expressions that represent each person's number of hours. So here's Hugo. He works X hours. It says up here that Patricia works 3 more than twice the number of Hugo, right? So 3 more, there's the 3 more, then twice Hugo. So that's 2 times how many Hugos, right? So 2 X's. So here, twice Hugo, if I'm doing twice Hugo, then this expression is going to be 2 times X. And then we're going to add the other 3, so we've got 2X plus 3, right? I forgot to put over here, Hugo is just X, right? And then over here, it says that Son works 2 less hours than Hugo. So here, it's 2 less than Hugo. So we've got 2 negatives and Hugo's. So this expression is going to be X, what? Minus 2. Very good. X minus 2. So here we're going to identify parts of an expression. When addition or subtraction signs separate an algebraic expression into parts, each part is called a term. Please make sure you write down that definition. So a term is each part of an algebraic expression. So here's a reminder. It says, recall that the numerical factor of a term that contains a variable is called a coefficient of the variable. So the number in front of the variable is called the coefficient. Like terms contain the same variables raised to the same powers. Okay, so here the like terms that we have available in this example, we have 3x squared and negative 7x squared. These are like terms because we have both x's and they're both raised to the second power. Is everybody clear with that? If it was x squared and x to the third power, then we would say those are not like terms. Now a term that has no variable is called a constant. So I would like you to draw this diagram and then label the parts, okay? So again, a term is each part of an algebraic expression. So negative 4x is a term, 12 is a term, and x is a term. So here the terms, they are separated by an addition sign or a subtraction sign, okay? The like terms are the terms that have the same variable that have the same exponent. So here, these are x to the 1 power, x to the first power. So those are just x terms. So negative 4x and x are like terms, okay? And then 12, because there is no variable on it, that is called a constant. So example 1, here we're going to identify the terms, the like terms, the coefficients, and the constants in the expression 6n minus 4 plus n. Okay? So here, we are not going to rewrite. So We're not going to rewrite, but we are going to keep in mind what we just learned with the distributive property, that the operation is also the sign of the number that follows. Okay? So, when I identify my terms, you can see that 6n is a term, right? You can see that 7n, what kind of 7n?
Negative.
A negative 7n is a term. You will see that, what's this next one?
Negative 4.
Negative 4 is a term. And then you will see that, let's use purple. You will see that that's a positive n is a term. And do I have to write the plus in front of the positive n?
No.
So you just write n. Is everybody clear with that? Okay. So the like terms, remember like terms are the variables that have the same, the terms that have the same variables raised to the same exponent. So which ones have, describe that? This is an n, this is an n, and this is an n. All three of those are your like terms. You got it? The coefficients. The coefficients are the numbers that are in front of the variable. Okay? Let me erase this a little bit. Let's erase this. So, the coefficients are the numbers that are in front of the variables. So, here, in front of this n, we have 6. In front of this n, what do I have? I have negative 7. Very good. Don't forget that sign, that operation is also the sign of the number that follows. And then in this one, very good. There is a 1 in front of here. Does everybody see that? So that is a positive 1. How many n's do I have there? 1. If I had 2 n's, it would be 2n, right? If I had 3 n's, it would be 3n. If there's only 1 n there, it's 1n. So there's the 1 that represents the coefficient. Is everybody clear? All right. And then the constant is the term that has no variable. Which one is that? Negative 4. Very good. So the constant is negative 4. You got it? All right, so for the got it, we are going to identify the terms, the like terms, the coefficients, and the constants in each expression. So, for example A, we have 9y minus 4 minus 11y plus 7. So the terms we have are y and negative 4 and negative 11y and a positive 7. All right, so those are the terms, keeping in mind that the operation is the sign of the number that follows. Okay? So, the like terms are the ones that have the same variable raised to the same exponent. So, that would be which ones? Very good. So, the like terms are 9y and negative 11y. Now, I must say also that constants are also like terms because I can put constants, I can put terms that have no variable, I can add them together, right? So, also, negative 4, I'll put this in blue, negative 4 and positive 7 are also like terms. So coefficients are the numbers that are in front of the variables. So let me erase this. So the coefficients here, what are my coefficients? Not the y, just the number in front of the variable are the coefficients. So we have 9 and negative 11. Is everybody clear with that? It's just the number. The coefficient is just the number in front of the variable. Okay? And then the constants are the terms that have no variables. So which ones have no variables?
-4
Very good. -4 and 7. So now we're going to simplify algebraic expressions. It says here an algebraic expression is in simplest form if it has no like terms and no parentheses. Please make sure you write that down. We're going to use the distributive property to combine like terms. So, for example, we have 4y plus y, and we want to write that in simplest form. So, here, when we simplify algebraic expressions, all we're doing is we are combining like terms. So, is 4y and 1y, are those like terms? Yes, they are. So now we can add them together. So, and don't forget, in front of that y, there is a 1, right? So we have 4y plus 1y. So 4y plus 1y is 5y. So for example 3, it says, write 7x minus 2 minus 7x plus 6 in simplest form. So once again, we want to identify our like terms. So here, the like terms that we can combine are 7x, and what kind of x is 7x is that one? That's a negative 7x. So 7x plus negative 7x, or minus 7x, is 0x. Now, 0x means 0 times x, right? What's 0 times x? 0. Right? Is everybody clear with that? And then the other one that we're going to combine, the other like terms are the negative 2 and the positive 6. So here we have negative 2 plus 6, which gives us positive 4. So here, 0 plus 4 is 4. Let's do the got it's. So example C says 4z minus how many z's? 1z. Very good. So this is 4z minus 1z. That's going to give me 3z. Because we have 4 minus 1 is 3. Is everybody clear? Now please remember, you do not subtract the z's. Just the coefficients. You got it? All right. So now, looking at example D, we have 6 minus 3n plus 3n. So the like terms, negative 3n and a positive 3n. Oh, what are those? What are they called? Additive inverses, or opposites, right? So here we have 6 plus 0. You don't really have to write the plus 0, but I want you to do it in your notes, just so you know that that will remind you that those are additive inverses. And then we end up with 6. Got it? All right, let's look at the next one. So we have 2g minus 3 plus 11 minus 8g. The like terms are 2g and 8g. Oh, you know what? I'm going to do this the way I'm going to do this the way if you guys don't have highlighters, okay? This is how I do it when I just have a pencil, okay? The like terms are 2g and 8g. The other negative 8g, thank you. And the other like terms are negative 3 and positive 11. Does everybody see, since I don't have a highlighter, I just use shapes. Okay, so then you can see what your like terms are, and you can see what you're going to put together. You see? So 2g minus 8g is negative 6g. Very good. Negative 6g. And then negative 3 plus 11, positive 8. So, example 4 says the cost of a jacket, J, after a 5% markup can be represented by the expression J plus 0.05J. Does everybody understand that? Because it's the cost of the jacket, and then it's marked up 5% of the original cost, right? So 5% of means multiply, and that's why we're multiplying 0.05, which is the parenthesis percent written as a decimal. You got that? So here's the expression. They gave it to you. If they didn't give it to you, then you'd have to go through all that thought process, okay? We want to simplify the expression, then determine the total cost of the jacket after the markup, if the original price is $35. So the first thing we want to do is combine my like terms. So J plus 0.5J is 1.05J, where that's multiplication, right? So then it says, determine the total cost if the jacket after the markup if the original price is 35. So here, the next thing we're going to do is we're going to evaluate this expression when J is equal to 35. So, evaluate means what? Substitute and simplify. So wherever there's a J, we're going to write 35. So 1.05 times 35 gives me $36.75. So the cost of the jacket after 5% markup is $36.75. So for the got it, it says write an expression in simplest form for the cost of the jacket in example 4 if the markup is 8%. Then determine the total cost after the market. So we're going to use the same information that we have up here to write our expression. So we'll say again that J is the jacket. That's the cost of the jacket. The markup is 8%. So 8% of J, right? So that's going to be 0.08 times J. Is everybody with me? So what's in front of this J over here? 1. Not nothing. That's a 1, right? So 1J plus 0.08J gives me 1.08J. And this is my simplified expression. So now we can evaluate when J is equal to $35, right? So we have 1.08 times 35, and what does that give me? So now we're going to multiply 1.08 times 35, and that's going to give us 37.8, which is how much money?
$37.08.
Very good. What was it? $37.80. And don't forget your symbol. Example 5 says, at a concert, you buy some t-shirts for $12 each, and the same number of CDs for $7 each. We want to write an expression in simplest form that represents the total amount spent. So, they bought 12 t-shirts and how many CDs? Actually, we don't know how many t-shirts. The t-shirts cost $12. And then we bought the same number of CDs that cost $7.50 each. So we don't know how many we bought, right? So that's going to be our variable x. So the expression 12 times x, that's the number we're buying, plus $7.50 times x is going to be our expression. So now we're just going to combine our like terms. So 12x plus $7.50 x. Combining our like terms gives us times x. Very good. Now that's the expression that's going to give us the total amount. And if we knew how many of each one we bought, then we can just evaluate for that number, right? All right, very good. So let's do this. Got it. You have some money. Your friend has $50 less than you. Write an expression in simplest form that represents the total amount of money that you and your friend have. So, do we know how much money you have? No. So that's going to be our variable. So x is equal to your money. Okay? Now, your friend has $50 less than you. How am I going to write how much your friend has? Not just negative 50. X minus 50. Right. Because your friend has $50 less than you. So this is your friend's money. So x is your money, and x minus 50 is your friend's money. And if I want to know how much money you have all together, you're just going to add them together, right? So we have x plus x minus 50. Is everybody with me? So now we can just combine our like terms. So here we have an x and a positive x. So that's going to give me 2x. And then we just have to put the rest of it onto the expression. So 2x minus 50 is the expression that represents how much money you and your friend have in total.